Hello, my name is Norm Stein. I'm an aeronautical engineer, have been for quite a while, maybe as long as 65 years. And I want to describe a little bit about a new class we're starting in the fall for our series on Introduction to Aerodynamics. And for those of you who haven't been associated with the classes, I can tell you a little more about myself. I started my education in aerodynamics and engineering in general about 1944. So I'm kind of an old guy, 86 years old. But most of my education really came from Caltech, although I didn't get a degree from Caltech because I couldn't afford the tuition. But that's neither here nor there. I do have degrees from other universities. And so I have been teaching this course now for about a year and a half. We've had like 5 or 6 semesters starting January 6th, 2011. It's been very exciting for me and for the students too. We've done some really interesting things. We've built gliders, full-scale zipline gliders, and we've built model airplanes. But we've really put accent on the mathematics and physics of aeronautical engineering. And we've held up the things like model airplanes and flying the zipline gliders as, you know, incentives to keep our students interested, and it has worked. But we still put the greatest emphasis on real engineering. And so in the fall of 2012, we have a class planned that we've been talking about and wondering how to do from the very start, from January 2011. We've always wanted to build a wind tunnel and have model testing. And it's been a difficult thing to see how to do, but finally we've accumulated enough materials and apparatus and knowledge by seeing what other people have done so that we are going to build a wind tunnel and we are going to test models starting in the fall in our Introduction to Aerodynamics class. The class will have 2 very important things to teach. Number one, kind of obviously, how does a wind tunnel work? But not quite so obvious is what are its limitations. Because there's so many people that think, oh well, you take a model of an airplane, you put it in a wind tunnel, you learn everything you need to, go build the airplane and fly it. You know, does Boeing do that? No. Does any other airplane company do that? No, they don't, because the wind tunnel has so many limitations. Even very expensive full-scale wind tunnel has some very important limitations. The data you get from it is relative. The model is not that perfect compared to the real airplane, but you can get relative data of configurations. You can do that with models too, and we're going to do that with our own small wind tunnel. We're going to show how it works, and when we get done, and the class members will be building the wind tunnel. And when they get done building it, they'll be operating it. When they get done with that course, they will know more about wind tunnels than almost anybody, really. They don't teach that kind of thing in graduate school. But the second thing they're going to learn is how you get airplane design data by testing the models in a relative sense. And we can do that ourselves. We can make our own little models, and we can change the models, and we can show what the difference is in that model's lift, drag, and pitching moment and its performance. We can do that just as great and just as good as any university or NASA or anybody else. Really. Now, there's something else that's really important about the class that we're going to teach. And we've learned this ourselves. Nobody taught us this, and it's something called teamwork. We have made apparatus for testing propellers, model propellers. And it's been exciting for our students because they have designed a propeller based on very little information, and they have tested it, one student's propeller against another, and how exciting that some of them are great and some of them are lousy. And it's been a wonderful learning experience. And you just can't imagine the cheering and the excitement and the laughter that goes on testing model propellers when one guy's is so much better than another guy's, or one girl's is so much better than one boy's. And it's just a fantastic experience. We had to experience that ourselves to understand teamwork, because our students had to work together. Engineering tests require a team, and they had to work together to perform those tests. You can't just walk up to a test apparatus by yourself and run a test. You need to talk other people into monitoring instruments and to helping you do things. So we did that at first with model propeller testing. And incidentally, the equations and the process we use there we got from NASA, very same process they've been using for testing model propellers from middle 1920s. The other testing we did was tension testing, not just associated with aerodynamics, of course, because, you know, engineering in general requires strength of materials and tension testing. We did some of that. We made our own apparatus here, and we did tension testing, and when that test specimen would snap, you know, the students would be so surprised, they would be startled, and they would laugh. And then when the next test ran, everybody's ready for that. You know, when's that test specimen going to break? Snap, more excitement. And some test specimens were stronger than others. Same experience. Really, teamwork. It took more than one person to do one test. So we learned that, and I'm mentioning this because I'm sure this is going to apply to our wind tunnel testing. And finally, an associated activity will be solving a few aerodynamic equations. And we do this every class. We require this to be done before the fun part takes place. And you know, like I have the equation behind me here for dynamic pressure. Q is 1/2 rho v squared times our constant 0.067 for dynamic pressure. And I really like all the students to memorize that. We have some students who don't have much mathematics, so we have those who are more experienced teach those who are less experienced. We've had students that couldn't square a number, but after 10 minutes of explaining it to them, they can square a number. We have students who didn't understand that each of these things had a value associated with it, and then you multiply them all together. You know, that's not obvious. What is this thing? Is this a word? You know, what is it? It's a series of numbers. Each of these things has a value. This is rho. We teach them, you know, it's a Greek letter, so what? Everybody uses rho for density of air. Yes, air has density. What's density? We talk about that. When we get done talking about this, our students, whether they're 10 years old or 16 years old, they've got it. And so they learn dynamic pressure. And there's a few other things like this. Aren't very complicated. Those of you who are listening to the description of the course went through that in your education a long time ago, probably. So we go through that, and we make sure that everybody knows how to do that. So that's the description, and thank you for listening to me.